So how many people here have been to a birthday party? I know I did when I was a kid. We had birthday parties all the time, all the way up until I was probably maybe 8 or 9 years old, maybe a little older. But we did this old trick, and we took a balloon and we rubbed it on our hair. That's when I used to have hair. And the electrons would jump from my hair onto the balloon. So this is a common thing you did. Okay, so you took a balloon and you rubbed it on your hair. So here's the guy's hair. Okay, so you rub a balloon on hair, and the balloon acquires a negative charge. Okay, it actually strips the electrons from the hair and brings it over to the balloon. Now what we do is we take the balloon, we can stick it to the ceiling or the wall. Okay, and the negative charge, okay, actually on the surface of the ceiling, the negative charges pull close to the positive charges on the ceiling, and so we actually can pull up with a greater force. Greater force than gravity, so we can actually stick the balloon to the ceiling or to the wall. So that tells us a little something about electric charges. Number one, like charges repel. Okay. Number two, opposite charges attract. Okay, so if the charge is opposite, if we have a buildup of electrons on one side and then a buildup of protons on the other side, then these two will attract each other. Okay, and quite the opposite happens when we have negative charges close to negative charges. Okay, they actually repel each other. So if I have an electron and another electron, okay, they are going to repel each other. Okay, if I have an electron and then a proton, this is the symbol for a proton, they are going to attract each other. Okay, very important part of physics here. Likes repel, opposite charges attract. Okay, like charges repel, opposite charges attract, and we're going to learn like how much, okay, this attraction is, and how to actually create the attraction. So in class, I'm going to show you, classic little experiment where we take something and rub it onto like rabbit fur, and we take off the electrons from the rabbit fur and put it onto like a rod, and the rod will actually pick up some pieces of paper. So we can charge things two ways. When we charge things, we're actually taking electrons and putting them onto the surface of the object. So we can charge two ways. Okay, the first way is by conduction. Okay, and that's with physical contact. Okay, we can charge that way. The second way we can charge something is by induction. Okay, which just tells us that it's physical proximity. Okay, so physical, not contact, but proximity. This is charging by touching. This is charging by not touching. So let's look at conduction first. Okay, conduction, okay, is charged by touching or contact. Okay, you can look at the first part of the word conduction, contact. Okay, so the first way we convert a charge is to when we conduct something is our typical example, and you'll see these examples in class. We rub a balloon on our hair, and it transfers electric charges to one side of the balloon, or the surface of the balloon, and charges it that way. We actually rub the balloon on something, and that would be our hair or some rabbit fur. Okay, that's conduction. Okay, that's actually touching. And then we can charge that object up, and now we have an object that's charged, okay, more negatively than positively. And then when we put it next to another object, let's say a ceiling, okay, that's got equal numbers of charges, okay, it's neutral, the positives move toward the surface, and then the negatives of the balloon attract itself to the positive of the surface of whatever we're putting it on. So now we can use this charge to hold the balloon. Sometimes I would do this. This is really mean. But we used to have cats growing up, and so what I would do is I would and I didn't realize I was doing this, but I was, if I pet the cat. So here's a picture of a cat. Okay, let's just draw a picture of a cat here. There's his nose. Looks more like a pig. That's okay. Here's our cat. I used to have this like really fuzzy cat. And what I would do is I would take my hand and rub the back of the cat like this, and just like rub him, and pat him, and he enjoyed it. And then what would happen is, I didn't realize this, but when I was a kid, I put negative charges all over my hand, and then since my hand was charged, I would take and I would touch the cat on his nose, and the charge from my hand would actually jump to his nose and create like a small spark. I know it's a weird thing, but it actually was poor cat. I put him through hell. I would charge my hand up and then touch his nose, and it would jump. The charges would jump from my hand to his nose, and partially because the nose is part of the body which is grounded to the ground, and so the electrons found a way to escape and then get back to the ground, and that's another thing we'll talk about later is grounds. Another mean little trick you could do to a friend is take your shoes off, okay? And if you have carpet at home, carpet is fuzzy and carries a lot of electrons. And so if you take and you rub your feet with socks on, and you rub your feet on the carpet, you become negatively charged. Okay, you become negatively charged on your surface. Okay, so if you rub your feet on the carpet and then you go and you touch and you put your hand on your friend's face or their head or something like that, they'll get shocked because they're not negatively charged. You are. Those electrons want to jump over to your friend who's not negatively charged. So the electrons, once you make contact, they jump, and sometimes you feel the spark. Okay, and there's a pretty good voltage decrease when you release your electrons. Okay, a little on induction. Okay, induction is charge by proximity. Charge by proximity. That means you have, let's say, a charged sphere here, and it's got an equal number of positive and negative charges on it. Okay, and then you take, let's say, a rod here that's, let's say it's negatively charged. You place it in proximity to this sphere. Now, what do you think is going to happen with these negative charges and these negative charges? Well, they're going to repel each other, and this is going to reconfigure itself to look more like this. Okay, because I've got a charged rod here that is going to pull in the positive charges, okay, closer to it. So we can also, without touching, charge by proximity. Okay, I can also look at this in the opposite way, and I can say that if I have a sphere here, okay, and I have positive charge here and negative charges here, that my positive charged rod can negatively charge this sphere to bring the electrons to the surface, which is pretty cool. A lot of times you can see this with your cell phone, okay, and you can, it's kind of odd, but you can charge a cell phone. You guys have seen this little thing. Okay, there's like this little puck that you plug into the wall, and then you just put the cell phone on top of it. Okay, there's no metal touching here, but you can charge your cell phone by induction here, which is pretty cool. This just maintains a healthy level of positive charges, and this then charges the phone, brings the negative charges out, okay, of the phone, and this charges it so you can use it the next day. So our electronic devices use this property as well. Now the phone I have actually uses conduction, which is a direct contact charge.